Welcome to a new AG session all about analytic geometry. We are tasked to find a value of x for a certain point 2 with the composition of x and 2 together with the initial point 1 at 1 and 5 will have a distance of 5 units. Let's illustrate that first here. Our initial point is at 1, 5, considering all these grids are per 1, and of course we have here our x-axis and we have here our y-axis 1, 2, 3, 4, and 5. This is our initial point 1, okay, at 1 and 5. Now we are going to locate a certain point in with the composition of x and 2 with 5 units distance from this. Take note that the second point given has a specific y value of 2. This would mean that this certain line here, okay, this is where that point should reside because this is y at 2. So there must be a certain point here. Let's say for example, this point, we are not yet telling this is the correct answer, just an assumption. If this is that point, the distance from our initial point to this point 2 will be 5 units. But here's the thing, we don't have exactly one answer because we could have two answers here, 2 points, in short 2 values of x. Because if we're going to talk about the other side, you could also come up with a certain point here. Again, this is just an assumption, a certain point here that will have the same distance of 5 units from the same initial point. This would mean there are 2 possible values for x here. Okay, let me remove this and to continue further with our discussion. Of course, what was given is that the distance of point 1 to that point 2, but then again there are 2 points. Nevertheless, the distance is 5 units. But we know that the formula for distance on the same points, okay, the distance for that is given as this expression. You have this expression here, x sub 2 minus x sub 1, their difference, you square that, plus the difference of y sub 2 and y sub 1, and you square that as well. Together with the radical expression, this is the entire distance formula. Knowing that this is the given and this is the notation for the formula, we could say by transitive property that the entire expression, the square of the difference of x sub 1 and x sub 2 plus the square of the difference of y sub 2 and y sub 1, and under a radical expression of square root will be equal to a value of 5 units. So this would be the strategy that we are going to apply here. Now, we already have a value for our initial point 1, which is 1 and 5. This is the point here, 1 and 5. Since this is our point 1, this would be our x sub 1, this is our x sub 2. So by substituting here, okay, we will have minus our x sub 1, which is 1, plus our y sub 2 minus y sub 1, which is 5, and you square that as well. This would be equal to 5. Now how about our entries here? This is for our point 2, which is expressed as x and 2. X, that would be our x sub 2, and 2 would be our y sub 2. With this expression, we can now see only one variable present here, and that's the goal of solving for this task. Now, before we continue, let's take the square of both sides. Square that. Square this as well. So we will be removing the radical expression here, not here, this one here. Okay? So it would be the square of x sub 1, which could be written as x minus 1 times x minus 1, because there are 2 binomials x minus 1 multiplied with each other, plus the difference of that is negative 3, but you have still the square here because that's not the square that we have removed, it's here, is equal to the square of 5, which is 25. Please don't forget this side as well. Now let's continue here using the FOIL method. We have the first x times x, x squared. Inner -1 times x is negative x. Outer x and -1, another negative x. So we have minus 2x, -1 and -1 plus 1 here plus 9 still equal to 25. As mentioned earlier and by illustration in our Cartesian plane, we have analyzed that there are two possible values for x. There are 2 points in short. This is also indicated by this. We have here x squared quadratic expression indicates that there are 2 possible values for x here. Let's just simply try to simplify this further. We have minus 2x. Of course, this is plus 10 equal to 25. Let's subtract both sides by 25. So we will have a quadratic equation here, 2x. So 10 minus 25 is minus 15 equal to 0. This time we are going to factor this to solve for x. That's a goal. We can use here the AC method if you would like to. AC, multiply a, the coefficient of x squared, which is 1, and your constant, which is negative 15. The result for this is negative 15. Now we are going to look for factors of negative 15, a pair of factors that when multiplied will get negative 15, but when added will result to minus 2, the middle numerical coefficient. That's actually negative 5 and 3. Because negative 5 times 3, that's negative 15. Negative 5 plus 3, that's negative 2 here. So the factors are binomial expression x, copy the coefficient, x minus 5, times x, and you have here plus 3 equal to 0. To move further, this is only true if one or both of them, both binomial expressions, are equal to 0. So we're going to solve for the values of x using these two. So x minus 5 equal to 0, x plus 3 equal to 0 according to zero factor or zero product property. This would mean x is equal to positive 5 and x could also be equal to negative 3. Notice there are 2 possible values of x. Our second point has compositions x and 2. This would mean the 2 points here, the first point using 5, you have 5 and 2. Going to our Cartesian plane, 2, 3, 4, 5. This is the point together with our initial point. When drawn a line, the distance or the length of this segment or a distance again of point 1 and this first point 2 is equal to 5 units. But the other point using the second value for x, negative 3 and 2, so you have here negative 1, negative 2, negative 3, it's here. This has the same distance from point 1, which is in 5 units. As we have established earlier, there are 2 points that would satisfy the given situation. And we use here the concept of distance formula, the quadratic equation, factoring, and all necessary steps in order for us to solve for the value of x. Thank you for watching and stay tuned for another session here in AG for Analytic Geometry.